As its name suggests, when two populations are in competition, they are fighting over the same resources. Do not get competition between populations confused with the competition within a population. We are concerned with the competition between populations, and this is called inter-specific competition, whereas the competition within a population is called intra-specific competition. So competition doesn't actually happen that often between populations because of the competitive exclusion principle. This principle states that when two organisms compete in the same niche over time, only one will survive. An organism's niche is made of the biotic and abiotic factors it needs in its environment. So, for example, it would include the temperature range that it is adjusted to, or it would include the time of day or the time of year that it is active, or the food it needs, and so on. So living in the same niche means that two populations of organisms share the same exact resources, and when this happens, one organism population will always have some biological advantage over the other, whether they are stronger, swifter, faster, or more adapted to the niche. And over time, what that more adapted organism population outcompetes the other organism population. So here we kind of have a bit of a dilemma because we said that competition is negative for both organism populations. And indeed in the short run, that is true because while two organism populations are in competition, a lot of individuals die from this competition. However, in the long run, because one organism population will eventually outcompete the other, it becomes a positive-negative interaction. The positive being the benefit to the organism population that is stronger. So, what is the deal here? If two organism populations are competing, is one always wiped out? And the answer is no, because there are two options for disadvantaged organism populations that they can use to avoid exclusion or avoid competition, and one is called resource partitioning. And in this, an organism population adapts to use different resources, and once it starts using different resources, it changes its niche. So the other option is called character displacement, and this is when both organisms undergo divergent evolution in physical characteristics to give them access to separate niches. So a primary example of this would be Darwin's finches. And you can see that these two finches, when living together in this graph, have different beak sizes. So the orange background finch has a smaller beak size than the bluish-green background finch right here. What's interesting, though, is that these two same species of finch, when found living separately on different islands in the Galapagos, have pretty much the same beak size. You can see they pretty much lie one on top of the other. Why is this? This clearly shows that when these two finches, whose natural niches are to have the same beak size, live together, they change their beak sizes so they can have different niches. And so the smaller beak size will be more adapted to eating smaller seeds, whereas the larger beak size will eat larger seeds. So you can see that as long as two organisms are living in the same niche, they have to compete and one will be excluded. But to avoid competition, all they need to do is change their niche through two different techniques, and all will be well.